Okay, good morning and welcome to our first lesson on solving quadratic equations. So we spent a long time focusing on the process of factoring. And this is the lesson where we finally get to why. Why would we want to factor? What does factoring do for us that this is a useful skill? Now this lesson begins with an activity where you played with some numbers. And it's an activity that I think will work better virtually than works actually by hand because of the ability to drag stuff around the computer screen. But the point of that activity was to illustrate some things about numbers and the properties of numbers and why they do what they do. So as we get into solving quadratics, the first question we need to ask ourselves is, what are we doing when we solve a quadratic equation? So you're going to see these equations and the direction is going to be solve. What is it that we're trying to do? If we don't know what we're trying to do, then we won't be able to develop a strategy to do it or know when we've done it. Now, the answer to that question is going to look familiar to you. And I wanted to line that up, but it wouldn't let me change the color. Also, my upstairs neighbors are crashing through my ceiling. So if you hear strange thuds or rattles, it would be two small children that live upstairs from me, jumping on a pogo stick or falling on the floor or whatever they're doing. So I apologize for that sound. So the answer to the question, what are we doing when we solve a quadratic equation? We are finding the value or values. That doesn't look quite right. Hang on. There we go, that looks better. Finding the value or values of x that make the equation true. And that should sound familiar to you because that's been the definition of solution all year. That's the solution to a linear equation. It was the solution to a system of equations. We were looking for the values of the variables that make the equations true. When we graph something, we're looking for the pairs of variables that when you plug them into the equation, it makes them true. And so that theme is really, really key in math. If you can keep your eyes on that, then that will help direct how you go about attacking or solving a problem. So we're looking for the value or values of x that are going to make the equation true when we plug them in. It will also allow you to check answers for any multiple choice question if you know what the solution is. So if you have no idea at all how to solve an equation, but you know what the solution is, it's the value of the variables that make the equation true, you can always take those answer choices and plug them back in to see if they work. And in high stakes tests where every question matters, that is worth knowing how to do. So let's talk briefly about the activity that you did and what needs to come out of that activity. So in a face-to-face class, we would have this discussion together. I'd put some stuff on the board in a virtual setting where we would just be watching the video, and it's much, much harder for us to get that back and forth. It's a little bit easier just to summarize it. So in that activity, you needed to play around with your pairs of numbers and look for pairs of numbers that we're going to multiply to 24. And there's a couple of things that you might notice when you are looking for pairs of numbers that give you 24. So we have our pairs of numbers, and you should have come up with like 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And then you probably had the negatives of all of those. And there are some really good, useful observations that you might make about them. So I might have a couple of you write them or share some observations in the class discussion channel. And I'll pause the video for a moment for you guys to type in just some observations that you had in your group. Okay, now I'm not sure what kind of discussion that we have. Obviously, I'm going to play the lesson based off the interaction we have. Some of the common observations students make is that the two numbers, if they multiply to positive 24, they both have to be the same sign. So you have to have either two positive numbers or two negative numbers, but at no point were you combining like a positive with a negative. Or multiplying them to get a positive 24. Another observation that students often make is that at least one of the numbers has to be even. Now they could both be even, as in like 2 times 24 or 4 times 6, but they don't both have to be even, because in 3 times 8, just the 8 is even, and 1 times 24, just the 24 is even. But you have to have at least one even number. You can't take two odd numbers and multiply them together to get 24. And then the last observation that I usually want students to make is that you can't use the zero. It is impossible for you to pair the 0 up in any way that would multiply to give you a 24, because the moment you're multiplying by the 0, then the product has to be 0. And all of those observations are really good to make. They might be useful in one instance and not in another, but it's good to be paying attention to numbers and how they behave and what they do. Now, the second question plays off of that. If A times B equals 0, what can you tell me about the values of A and B? And what you really need to notice there is that at least one of the two had to be 0. So you could get a 0 by doing like 0 times 1, 0 times 2, 0 times 24, and you could do the 0 times 0. It's possible for both of them to be 0. You could have 0 times the negative. Okay, that would work too. Oops, I'm not writing very well here. Let's try that again. Okay, and the key idea there is that one of the numbers has to be 0. You can't get a 0 as a product without using a 0. If you have the product of 24, there are things you can know about the factors, okay? And notice I'm throwing out that key vocab word of factors. So if the product is 24, there's stuff that you know about the factors. You know they both have to be the same sign. You know that one of them has to be even. But you can't know for sure exactly what the factors are. Like, you could narrow it down, but we can't know for sure if that's all we have to go on. If the product is 0, however, I know with 100% certainty that one of those numbers has to be a 0. And it could be both, but at least one of them has to be 0. And that makes the number 0 like my favorite number because it has this unique property. And that leads us to our key concept, our key idea. This is like the linchpin for how this whole concept comes together. This key idea is called the zero product property. So notice the words in here, 0, this is going to have something to do with the number 0 somehow. Product means multiplying, and then property is a general rule that we can follow. And here's the zero product property. It says, if you have two things multiplied together and the product is 0, and this actually would also apply to more than two things. So if you have like 3 things being multiplied and so forth, you could take them in groups of 2 and it would still work. Then, so we have this nice if-then statement. Then A is equal to 0 or B is equal to 0 or both. In other words, and it's just what that activity is meant to focus your attention on. If you know that the product is 0, then you know that one or more of the factors has to be 0. That is, that numbers have to work that way. You can't take two numbers that aren't 0, multiply them together and have 0. So take a moment and just think that through and make sure that that idea makes sense to you. It is like obvious, because that drives absolutely everything for solving quadratics by factoring. So in true fashion here, I'm going to show you how we go about solving a quadratic by factoring. I'm going to work an example off to the side. I'm going to try to color code my steps so that when you're looking at your notes later, it's not just going to be a bunch of steps and you don't know what they mean. Like, you'll be able to look at the step and then look at how the step is executed and hopefully use that to solve the problems on your own. So the example that we are going to be doing is this quadratic equation. 2x squared equals negative 7x minus 3. Okay, that's the equation. Now, notice a couple things about it. Before we launch in, notice it is an equation. So we have moved from expressions into equations. Everything we've done up to this point has not had an equal sign in it. It's just been an algebraic expression that we have focused on being able to rewrite. Now we're going to look at equations, and as soon as you see equations, you know you can solve them. So what we're looking for is the value of x that when I plug that number in, I will get a true statement. So I'll get like 5 equals 5 or something. The first thing you need to do when solving a quadratic, with one exception, and that's if you're going to use completing the square to solve it, which is not that common of a strategy, you are going to set the equation equal to 0. And in other words, that means get everything on one side of the equal sign. Okay, get everything on one side of the equal sign, because it doesn't help you to copy down the steps, set the equation equal to 0, if you don't know what that means. I mean, then you'll stare at your problem and say, like, what does it mean to set it equal to 0? Just making it 0 appear somewhere. So what that means is you're going to take everything in that equation, you're going to get it on one side of the equal sign. I strongly recommend that you get everything onto the side where your A value is going to be positive. So you really want to keep that 2 positive. You could subtract 2x squared from both sides, except that's going to give you a negative 2x squared on the right hand side, and that is something that we usually try to avoid. So in this step, I am going to add, you know what, let me add, you can do this in one step. I'm actually going to do it in 2 just for clarity, but normally I would say do this in one step. So you're going to have 2x squared, add 7x, and then we still have the negative 3 over on the other side, and then we'll add 3. And just notice as we do that how our skills build. So you learn how to solve linear equations, you learn the process of inverse operations, moving things around in an equation, and now we kind of breeze right through it. Like, okay, we have a negative 7x, we're going to add 7x to both sides. And that's really how your math skills should build. Now, this is what we mean by set it equal to 0. Again, you can move everything to the left side or you can move everything to the right side, and I strongly, strongly, strongly recommend that you move it in a way that will make the A value positive. So that's what we mean by set it equal to 0. You're going to basically undo everything on one side and you'll have a 0 on one side. Now, that's because of this. We absolutely want to have that 0. That 0 tells us stuff that other numbers don't tell us. So we don't want to leave the negative 3 over there. I don't know that much. Like, positive 1 and negative 3 and negative 1 and positive 3. And so what? Like, that doesn't really help us. Step 2. Okay, this is what we've been building towards for weeks now. You are going to factor whatever you have on whatever side it is. So we're going to take this expression and break it into 2 factors, an A and a B. We've got to go through that process of factoring. So this is a slide divide type problem. So I'm going to take my 2 and slide it down. And you can use any strategy you want. I should have gone through the part where we check for GCF. There is no common factor there. If there was, we would need to factor it out, but there's no common factor. Moving on then. So we want 2 numbers that, and I'm going to give you a second to think about it in your head, 2 numbers that multiply to and add up to. And you need to be able to fill that in. They need to multiply to 6 and add to 7, and you need to do enough problems so that you don't even think that hard about it. 2 numbers that multiply to 6 but add up to 7. Well, I've got 2 options, 1 times 6 and 2 times 3, and the one that adds up to 7 is the 1 times 6. And then we are going to divide by 2. And that's going to give us 2x plus 1 and x plus 3 equals 0. Whoops. There we go. Equals 0. Now, what we've done there is we've rewritten our equation in a different form, in what's called factored form. So we've looked at quadratics in vertex form and quadratics in standard form, and now we've got quadratics in factored form. But what we've done there is we've written it as A times B equals, good heavens, equals 0. And we know that if we have 2 things multiplied together and the product is 0, then one of these factors, or both of them, could have to be 0. Like, at least they one of them needs to be, and they both could be. So those are our options. All right, so let me move over to the next slide. Okay, now what I did right there, I just rewrote the two factors, and I wrote underneath it a times b because I really want you to make that connection between we're taking two things and we're multiplying them together. Well, and we're getting 0. Now we know from the zero product property that that means that either a is 0 or b is 0. That's the only way that this can be a thing. And so that's going to lead us to our third step, which is set each factor equal to 0. In other words, apply the zero product property. I'll abbreviate that ZPP. So I've got two factors. I have a factor of 2x plus 1, and I have a factor of x plus 3. We're going to set each of those equal to 0. That's where the equation splits into 2. And you guys can't see me, but my hands are all moving all over the place recording this video. I'm very enthusiastic about it. So the equation splits into 2 because we have two possibilities, and it's going to lead us to two answers. And you do have to get both of those answers. I just want to make sure I don't duplicate a color. So we're going to go with green. Then we are going to solve the resulting equations, and they should be pretty simple. 2x plus 1 equals 0, so subtract 1 from both sides. 2x equals -1, divide both sides by 2, and x is equal to 1/2. And this one, x plus 3 equals 0, subtract 3 from both sides, and x is equal to -3. And that's it. And the only last little note that I have in my notes, if you're following along, is you must get all the answers. Now, sometimes there will only be one answer. What will happen is you'll get the same answer twice. So you get like x is -3 and then another x is -3. It's the same answer twice. It's called the double root, which we'll talk about like later. Otherwise, you'll get 2. You might end up with what's called like a complex answer, but that won't happen when you're factoring, so we're not going to worry about that yet. So I actually have 2 solutions, x equals -1/2 and x is equal to -3, and there's your strategy. So if you're watching this on your own and you'd like to go back and just rewatch the example problem, get the explanation of the steps, what we're doing and why we're doing it. If you're bored, which you're probably not, but let's just say hypothetically you are, and you wanted to check the answers, okay, let's go ahead and check the -3. So we would take 2, we're going to plug in -3 equals -7, and then we plug in the -3. Got to plug it in both places. Follow your order of operations. So, sorry, -3 squared is 9. And then this would be +21. 2 times 9 is 18, and 21 minus 3 is 18, and we get our true statement. I would not recommend going through the check frequently because it can be kind of nasty. Let me look at the other one. I don't know if I can talk and check at the same time, but we'll see what I can do. If you plugged in the -1/2. Yeah, this is not as nice. But I would check the answers. One, if I had a calculator and I knew how to do it. So I will be posting some videos on using the calculators for ways to check your answers. It's super easy. And if you have a graphing calculator, you're going to be happy you have one. Or I would check them with high stakes tests. So I would check them like during the SAT if I had time. I would even check them on a classroom test. If you have time to go back and check them. I would not bother checking them on your homework because it's too time consuming and it's not high stakes enough. There's not enough at risk if you get it wrong. This would be what, +1/4. I just did 1/2 times 1/2, which is 1/4. and do a little scratch work over there. This is negative. Oh, wait a minute. I forgot the sign there. It's positive. That's a negative 1/2, which makes this a positive 7/2 minus 3. That's great. 2 times 1/4 is 1/2. 7/2 minus 6/2, because 3 over 2, or 6 over 2 is 3. And then, of course, 7 minus 6 is 1. And you can probably think to yourself, like, I'm not that interested in doing that, and I wouldn't blame you at all. So that completes the first lesson on solving quadratics by factoring. Pretty much it's establishing the key idea and giving you a pattern or template so that you can start doing the homework. You can try to do it. But we have a couple more examples to work through. So give it your best, and I'll see you in the next lesson for some additional examples.